Hello friends, today I will discuss the induction proximity sensor. In this topic, I cover the necessity of it, construction of it, principle of operation and its applications. Necessity. It is basically an external non-contact proximity sensor used in robotics, and it is used or it is necessary to use this sensor to know the presence of metal near to this sensor or robot without physical contact. Next, construction. So this consists of a circuit like this. There is an internal circuit, and this is the high frequency magnetic field, and this is the sensing coil, and the detailed diagram of this is like this. This is the coil. This is called the sensing coil, and this sensing coil is connected to the oscillator, and this oscillator frequency is radio frequency. The range of radio frequency is 20 kHz to 300 GHz. The speciality of this oscillator is it provides the high frequency to this coil, sensing coil. The other feature of this is if the magnetic field associated with this coil reduces, automatically the frequency of operation of this oscillator also reduces. So that is known by frequency detector here, and that will be converted into analog to digital, and that is conveyed to the robot controller. And this is the object to be sensed, or this is also called sensed object. The real-time inductive sensor is like this. This is the metal or this ferrous metal to be detected, and this is the induction sensor, proximity sensor, and this is the load, and this is the supply given to the sensor. Next, coming to the principle of operation of this sensor, due to the presence of this oscillator in the circuit, it provides high frequency magnetic field with the help of sensing coil. When the external metal comes near to this, then automatically the high frequency magnetic field reduces its magnitude. That is, the frequency of the oscillator changes, that is reduces, and that reduced frequency of the oscillator is conveyed to the frequency detector, and frequency detector convey the same message to the analog to digital converter, and that information, digital information, is conveyed to the robot controller, which identifies that there is a metal coming near to the coil, a sensing coil, without physical contact to the coil. So the waveforms we can observe in the oscillator is like this. When there is no metal near to the proximity sensor, the waveform of the oscillator will be like this, means it will have the maximum amplitude and also high frequency. That frequency is ranging from 20 kHz to 300 GHz. But once an object or target metal comes near to the sensor, then the magnetic field frequency reduces, that is its magnitude reduces, then automatically the magnitude of amplitude of this oscillator also reduces, and its frequency also reduces like this. So this indicates there is a metal which is near to the sensor. This is what is required for the robot controller. Applications. This is used in the industrial automation and manufacturing to detect the presence of metals, and also used for knowing the position of metallic objects without physical contact. Let me summarize once again the induction proximity sensor. In this device or sensor, when the target metal comes near to the sensor sensing coil, then the magnetic field frequency is affected by this metal. Once that is affected, automatically the sensor load increases. Once the sensor load increases, automatically the oscillator frequency reduces. That reduced frequency is conveyed to the frequency detector, and frequency detector converts the analog to digital form, and that digital form is conveyed to the robot controller, and robot controller comes to know that there is a metal which is near to the sensing coil,